Assalamualaikum and good day. Okay, this is the part 2 for continuity. Okay, for in this example given to us, this piecewise function. So we need to determine whether f(x) here is continuous at x equal to 4. Okay. Okay. Like I mentioned earlier in previous video, I would prefer if you can draw the number line for the piecewise function. Okay, unless you are very clear with all the inequalities, is fine. Okay, if you are still unsure, it's better for you to draw the number line. Okay, so f4 equal to 7 because refer to this. Okay, x equal to 4. Okay, and in this inequality, this is one for the less equal to 4. That's why it is on the left. Okay, and this is greater than 4. That's why the function is on the right. Okay, next, remember to follow the step one by one. Okay, the conditions. Okay, the first condition would be determine whether f4 is defined. So f4 is equal to 7. That's why here f4 equal to 7. It is a constant. There is no x for us to substitute the value. So let it be constant. Okay, the second condition, we have here limit x cubed minus 15x when x approaches 4 from left, because this is the function when it approaches 4 from left. Okay, so substitute the value of 4. We have 4 cubed, which is 64, minus 15 times 4, which is 60, and the answer will be 4. Okay, the next one will be limit x approaches 4 from right. So this is where it approaches 4 from right. So we will use this equation here, this function. So x squared minus 16 over 2x minus 8. And when you substitute x equal to 4, it will be 0 over 0, which is indeterminate form. Since it is indeterminate form, you need to factorize and cancel the common factor. So here, x squared minus 16 is x minus 4x plus 4. Factorize 2x minus 8 is 2 times x minus 4. Cancel the common factor and then substitute the value of x. It is 4 times 4 divided by 2, which is 4. So, as you can see here, the value from right and left are the same. Okay. Therefore, limit f(x) when x approaches 4 equal to 4. This is compulsory. Since the limit from left is equal to the limit from right, please write the conclusion like this. So, limit f(x) when x approaches 4 is equal to 4. Okay, this is compulsory. Okay, and then since the function at x equal to 4 is defined, the limit at when x approaches 4 exists. So, we need to do the third condition, condition 3. Okay, for the third condition, you need to write first f4 equal to limit f(x) when x approaches 4. And then write the value 7 equal to 4. Okay, this is impossible. 7 does not equal to 4. So, just write not equal here like this. Okay, at first, obviously, okay, you will write equal to. But then, after we compare the value, it is not equal. So, just add the inequality here. The slash for the not equal. Okay, not inequality, for the not equal. Okay, and therefore, f(x) is not continuous at x equal to 4. Why? Because it does not fulfill the third condition. Okay? Okay, the last example number 4, given f(x), this piecewise function, we need to determine the value of a and b if f(x) is continuous at x equal to negative 1. So, this is the number line that I have drew earlier. So, it's up to you whether you want to draw it or not. But, it is suggested. Okay. Next, since f(x) is continuous at x equal to negative 1, it means that f negative 1 is equal to limit f(x) when x approaches negative 1. That means the third condition. This refers to the third condition. Okay. It fulfills all the condition, especially the third condition. Okay. And from here, we can conclude that f negative 1 is equal to limit f(x) when x approaches negative 1 from left, and is also equal to limit f(x) when x approaches negative 1 from right. Okay. Next, here, we need to compare one by one. So the first one will be limit x approaches -1 from left. This function, because it is from the left, okay, this, and it is equal to f -1. Why do I compare with -1? It will be redundant if we compare the limit from left and right, because at that moment you still can't solve for a and b. Okay, you need to rearrange the functions that it will be helpful for you, where it will be helpful for you, okay, to solve the question. Okay, from here we have this function, and substitute the value of -1, and 1 negative a equal to -2. So negative a is equal to -2 minus 1. So a is actually equal to 3. Okay, and the next one, limit b minus x when x approaches -1 from right equal to f -1 again. So which means we have this one equal to this and this one equal to this. Because if we equal to both of them, it will be redundant. Okay, there's nothing can be done. Okay, and here, since it is from right, we use this function. Okay, substitute the value of x equal to -1. It will be b plus 1 equal to -2. So b is equal to -2 plus 1, which is b equal, -2 minus 1. So b is equal to -3. Okay, that's it for continuity. I encourage everyone to do more exercises, and please follow the steps, write each condition clearly, okay, before you conclude. Okay, thank you everyone. Assalamualaikum. Have a good day.